corners of a right angle triangle with mutually perpendicular sides equal length, it will be 16 plus 16, which is 4 root 2 meters. Taking point of intersection of these lines as an origin, the magnitude of position of center of mass of the system. So how do you find center of mass? Center of mass is a position vector, that is m1 x1, it's a m2 x2 plus m3 x3 by sigma mi. Similarly, sigma mi by mi, sigma mi. Here x1 y1 is 0 comma 0, x2 y2 2 comma 4 comma 0, x3 y3 here is 0 comma 4 here. So center of mass m1, m2, m3 all are equal. So once they are equal, center of mass will be all get cancelled. Simply x1 plus x2 plus x3 by 3, which is here x1 0, x2 is 4 plus 0 by 3, y1 0, y2 is 0, and it is center of mass will be at a distance. Yes. The magnitude of position vector of the center of mass of the system. Magnitude center of mass assume somewhere here. So magnitude of position vector means 16 by 9 plus 16 by 9, which is 4 root 2 by 3, which implies x equal to 3. Here it is tuning fork resonates with a sonometer wire of length stretched with a tension of 6 newtons. So when the tension in the wire changes to 54 newtons, here it's a sonometer wire of length 1 meter stretched between. So here some weights are attached. Because of it, the tension in it is 6 newtons. Initially, tension is 6 newtons. And the fundamental mode of frequency will be, here L becomes lambda by 2. So lambda is 2. So V becomes, that is 2 into fundamental mode. Here lambda is how much? 2. So frequency will be let us say n1, which is v by 2. Velocity of a wave in a string is root of t by mu. Frequency will be 1 by root 2 t by mu. Here, when the tension in the wire changes, here it is 1 by 6 by mu. Say this is. When tension changes to 54 newtons, then frequency will be 54 by mu. So it is 9 into 3 into half root 6 by mu, which is 3n1. So n2 is 3n1. What he told, tuning fork produces 12 beats. So number of beats per second is beat frequency, which is n2 minus n1, which he given it as 12. 3n1 minus n1 is 12. 2n1 is 12. Here n1 is 6. The frequency of tuning fork is 6 Hz. A plane in a level flight at a constant speed, and each of its two wings has an area 40 meters square. Here it is one wing. These are two wings. So area of each wing is 40 meters square. Area of two wings is 80 meters square. So here, let us consider wing like this. So here speed of air over the lower surface, it is lower surface, it is upper surface. Speed of wave in air, speed of air, speed of air over lower surface is 180 into 5 by 18, that is 50 meter per second. Speed of air over upper surface is 252 into 70 to 70 meter per second. So here, let us apply Bernoulli's theorem. P plus half rho v square plus rho g h is constant. It is P1 plus half rho v1 square plus rho g h1, P2 plus half rho v2 square plus, he told a level flight, h1 is h2. This get cancelled. P1 minus P2. So because of this pressure difference, plane moves in forward direction. The mass of the plane, pressure here is force per unit area, which implies force will be half rho v2 square minus v1 into cross-sectional area. So here density of air is 1 kg meter cube. V2 is is 70 square. Here it is 70, 50. 70 square minus 50 square, and cross-sectional area is 80. So which implies force is mg. After simplification, it is half into 120 into 20. Wait, it is 96,000. So G is 10, get cancelled. So mass of the plane will be 9,600. The current in the conductor I here is the amount of electric charge. I here is rate of flow of charge is this. From here it is dq, here is I dt, which is 3t square plus 4t cube dt. Integral dq, the charge which flows between t equal to 1 to 2 plus 4t power 4 by 4 between 1 and 2, 8 minus 1, 16 minus 1, 24, 22. So that is Q here is 22 coulombs. That is the charge which flows through it. A particle moving in one dimension under the action of variable force, it is initially at time 0, it is at a distance 16 meters. The variation is given minus 3t cube plus, so velocity will be dx by dt, 30, 60 plus 16. Acceleration is dv by dt. So acceleration is 0. That happens when time is 2 seconds. But he is asking velocity of the particle during that. 36 into 2 plus 16 minus 36 plus 72 plus 16. 36 plus 16, that is 52 meter per second. Here, the radius of nucleus of mass number 64 is this one. So, irrespective of the mass number, density of nucleus is constant. So that is mass per unit volume. So here mass, this we will write it as atomic mass number. Volume is this, which is constant. That means this 4 by pi 3 is constant. A is proportional to R cube. A1 by A2 here is, so mass number is 64. And the radius corresponding will be for 0.8 Fermi, because both are in same units, no need of conversion. Then mass number he is asking when another nucleus having a radii 4 Fermi. So 1.2 whole cube. A2 will be 64 by, that is 1.2, yes, 1.2, which is 64 into 1000 by 4 3s 1000 by 27, which implies x is, because he is comparing this with 1000 by x. two identical charged spheres are suspended by string of equal lengths. These are two strings separated by an angle theta. Right. This is in air. When they suspended in water, angles remain same. So the next case, what he says, when they suspended in a water, angle remains the same. So if the density of the material of sphere, density of water is, okay, let us see here. What are the forces acting? Here mg, this is a tension. This one is, let us say it is theta by 2, which I will write it as alpha. So here we write T cos alpha is mg, vertical direction, horizontal direction, its component is T sin alpha. Here it is identically charged. There is a force of repulsion. Charge is Q, force acting on it is QE. T sin alpha is QE. T sin alpha by T cos alpha here is QE by mg. We get tan alpha is equal to QE by mg. Say it is one equation. Here also, since angle is same, here also we say tan alpha is both are charged the same way. Q, but E becomes E dash. So mass also changes because they are placed in water. So now I can write QE by mg is equal to QE dash by m dash g. So here, so E dash will be, because here it is E by K. K is dielectric constant of water. So it becomes E by M, E by K, M dash. So which implies Km dash is M. So when it is sphere is placed in a liquid, there is an upthrust. Upthrust net weight will be, it is mg. Upthrust will be volume into density of liquid into g. Your volume into density of that sphere in air into g. So m dash is equal to your density is mass per unit volume. Density, so VDL minus VDA. So Km dash is V times DL minus DA, which is M here, that is mass of that sphere in air, V times dA. So K will be dA by dL minus dA. So density of air, density of the sphere is 1.5 gram cc. Density of water is where it is. This is density of sphere, Vd sphere minus it is density of liquid. Here it is ds minus, right, this is ds 1.5, that is 1.5 by zero point 0.5. So dielectric constant is 3. The distance between object and its 3 times magnified virtual image is produced by a convex lens. The focal length of the lens used is here. To solve this problem, we should have a clarity over the sign conventions as well as how image is formed. So here, so this is convex lens. Here is its so object is placed between focus and the optical center. Then we will get a virtual image. Here, this one is focus. So object is placed here. A light ray parallel to the principal axis gets refracted and passes through the focus. Any ray which passes through the optical center, so that will not be deviated. So these two rays, if you extend it, so we get here a virtual image. Okay, here somewhere we get a this extended rays intersection virtual image we get. So this is the size of the object. It is the size of the image, size of the object, size of the image. Magnification of mirror is different from magnification of lens. Magnification of lens is m, which is for mirror we use minus b by u for. So rays are traveling like this. Object distance are measured from the optical center. It is minus u. Image is formed here. So magnification minus v by minus u, which will be equal to mu. From here, v is 3u. It is one equation. So lens equation is 1 by v minus 1 by u equal to 1 by. And here 3 unknowns. So 2 equations, one more is required. Distance between virtual image and object, that is this distance, is how much? 20 centimeters. that is mod V minus mod U, which is 20 centimeters. V is negative. We write minus V. U is also negative. Mod U will be minus. That is here minus V plus U is 20. So this one I can write it as, so which is here minus V is positive, U will be negative, and minus V is greater than this. So I will write here minus of V minus U is 20. So here it is V minus U will be 20. It is it V is negative minus V, and V is minus V is more than minus U, so it will be positive. So minus V plus U is 20. And here V is 3U. Minus 3U plus U is 20. From here U, you get it as minus 2. And 1 by V minus 1 by U is 1 by F. So here V is, U is minus 10. So we write plus 10. Here V is 3U minus 30. So here it is minus 1 plus 3. So focal length will be 15 centimeters. Here all the cells here, positive terminal of a cell is connected to negative. All are connected. Here positive terminal is connected to negative. So all cells are connected in a series. So net EMF will be, EMF net will be, so how many cells? 1, 2, 3, 4, total 8 cells are there. 8 into 5, 40 volts. Let us say I current is passing through this. So 8 cells, 8 internal resistances. Each resistance value is 0.2, 1.6 ohms. Right. So what is the current which flows through this? Will be 40 equal to 1.6 I. I here is, so 25 amperes current flows through this. So to find potential difference across AB, so here it is VB, current flows like this, minus 0.2 into I plus 5 volts, which is equal to VA. So VB minus VA is 0.2 I minus 5, 0.2 into 25 minus, which is 5 minus 5, 0 volts. A regular polygon of 6 sides is formed by bending a wire of length. L is length of wire, which is 4 pi meters. Polygon of 6 sides means it is hexagon. So AB length will be 4 pi by 6. That is 2 pi by 3. Length of each side will be this. Here it is 4 pi root 3 amperes current is flowing through the sides. The magnetic field at the center, so formula, magnetic field at a distance d from a current carrying wire, finite wire, sine alpha plus sine beta. So here it is 360 degrees. Uh, Totally in hexagon, each angle will be 120 degrees. And this will be 60. Here it is 90. This is 30. So current which passes is 4 pi root 3. And that D will be, it's a height of equilateral triangle, root 3 by 2a. So a here is length of this AB, which is 2 pi by 3. We get pi by root 3. So in place of D, I will write pi by root 3. Alpha is 30, even beta also 30. So here you get, here pi get cancelled out. Mu naught by 4 pi is 10 power minus 7 root 3 sin 30 half plus half. So here current is flowing in like this in a clockwise. Magnetic field due to this will be, here current is flowing in this by right hand thumb rule. So magnetic field direction into the plane due to uh, each finite wire magnetic field direction will be into the plane. So net magnetic field will be is equal to 6 into 12 into 10 power minus 7, 72 into Tesla. Answer here is X value 72. A monochromatic light of wavelength 6000 angstrom units. So here it incident on a single slit of width 0.01 mm. 1 mm is 10 power minus 3 meters. 10 power minus 3 meters. So diffraction pattern means A sine theta is n lambda. Here so intensity of a wave changes like this. So diffraction pattern is formed at the focus of a convex lens. So focus means that you assume it as a screen. So here from here to here, that is capital D, which is 20 centimeter. So here this is all brightness will be spread over this region between first minimus either side of the center line. So this angle is theta. Here this is angular width is 2 theta, but he is asking linear width. Linear width is this. Let us say it as y. Tan theta is y by d. So linear width will be 2y. If theta is small, theta will be tan theta is theta, and y will be 2y capital D. Here it is by A, which is y by D. Y will be lambda D by A, but linear width is 2y, that is 2 lambda D by A. Lambda is 6,000 angstrom units. 1 angstrom is 10 power minus 10 meters. D is 20 centimeters by 100. E is 10 power minus 5. 5 times, here it is 10 power minus 5, which is 12 by 5, 10 cube into this 10 power minus 2.4 into 10 power minus 2 meters, 10 power minus 3 or 24 mm. So here, next question. The minimum energy required by a hydrogen atom in ground state to emit radiation in Balmer series minimum energy and Balmer series, that is from second orbit to third orbit, so the minimum energy. But he told hydrogen atom in ground state, that is n equal to 1 to 3, that is E1 minus E1. En here is minus 13.65 n square. In first orbit it is minus 13.651. Third orbit, which is 9 ones 45. Here it is minus 5.1 minus 13.6, which is 12.1 electron volts. Here it is coefficient of kinetic friction is 0.04. Here 6G minus T, here is 6K. Direction of tension is away from the point of contact. So T minus here frictional force. That frictional force is mu K into N equal to 20. And here is mu into N is 0.04 into 200, which is 8. So T minus 8 is 28. 60 minus T is equal to 6A. Solving these two, we get 52 is equal to, so the acceleration is 2 meters per second. Here a particle moving in a circle of radius r with a uniform speed. So it takes time t to complete one revolution. It is moving in a circle of radius r. Time period will be 2 pi r by b. If this particle is projected with the same speed, that means this speed, at an angle theta to the horizontal, then maximum height attained by it, v square sine square theta by 2g, and that maximum height attained, he given it as 4r, and this is capital R, let us say time. What we have to find out is angle of projection a to gr by v square. Here v is 2 pi r by t, 4 pi square r square t square. So sine theta will be 2gr t square by sine square theta. Sine theta will be 2g t square by pi square r whole power half. Theta will be sine inverse 2g t square by pi square r whole power half. I think somewhere question it should be pi square. This is the typical sum in this session. A rectangular loop of side 12 centimeter and 5 centimeters. It is 12 centimeters. It is 5 centimeters. Moving with a velocity 5 centimeters per second. So it is moving in x direction and magnetic field in positive z direction. Magnetic field is positive z direction. So out of the plane. So I'll denote with k direction. Velocity I can write it as 5I. So here EMF induced will be B dot L cross V. Here if you consider AB, A to B direction and B direction are same, which implies L cross V will be 0. In case of DC also D to C, V direction, here also L cross V. So EMF is not induced in these two. Now, if magnetic field velocity and line segment are mutually perpendicular, then EMF is induced across the conductor. Problem is related to motional EMF. So here, if you consider BC, EMF is induced across this conductor. What is the direction of positive terminal? What is the direction of negative terminal? Here, negative terminal is that end which electrons moving due to magnetic force. But here it is Q times V cross B, force due to magnetic, here electron negatively charged. Here conductor is moving along X direction. So magnetic field is out of the plane, positive Z axis. I cross K will be minus J, it is plus J. That means negative terminal will be this side. Similarly for AD also negative terminal. Here EMF induced is even, here EMF induced is it. So both positive terminals are connected. So net EMF will be A2 minus A2. So how do we calculate EMF? So this, if you take a reference, magnetic field is B naught. So what will be the magnetic field? Because he told in the question that field has a gradient along the negative X direction. So with respect to X, field changes, and with respect to time also field is changing. So here magnetic field changing with respect to X and with respect to time. So let us calculate EMF which is induced in both cases. First with respect to X, here B naught, what will be the magnetic field here? He told that it has a gradient 10 power minus 3 t centimeters along the negative x-axis. So for each 1 centimeter, magnetic field increases by 10 power minus 3 Tesla. Here you have it is how many centimeters? 12 centimeters. For 12 centimeters, increase will be 12 into 10 power minus 3 Tesla. That means magnetic field across magnetic field at A B naught plus 12 into. So change in magnetic field B naught plus 12 into 10 power minus 3 minus B naught. Because of the change in magnetic field, EMF is induced. So that EMF, net EMF is E2 minus C1, which is 12 into B dot L cross V. Here L is length of the conductor. 12 into 10 power minus 3. LV, because conductor and this are mutually perpendicular. So here L cross V will be say J cross I, which is K. So we get 12 into 10 power minus 3 LV. Sin 90 is 1. We get length is 5 centimeter. Velocity also 5 centimeter per second. Converting in meters, 300 into 10 power minus 7 volts. So there is, with respect to time also, magnetic field is changing. This is also additional information what he given. So let us calculate what is the EMF induced due to change in the magnetic field with respect to time. That is B dot A. So here magnetic field direction and area direction, those two are parallel. I can write d by dt of dA. That is nothing but minus dB by dt dot A. So here it is with respect to time, it is decreasing at 10 power minus 3 Tesla. Area is 5 into 12 by 10 power 4. It is again 60 into 10 power minus 7 volts. Total EMF induced is one is due to change occurs with respect to distance, other is with respect to time. Adding these two, 360 into 10 power minus 7 volts. So power is nothing but V square by R, that is 36 into 10 power minus 6 whole square by resistance given it as 6 millivolts. I'll write it as 6 into 10 power minus 3, 36 10 power minus 12 by, which is 216 into 10 power minus 9 watts. So answer is 260.